All right, let's look at a couple of more examples of how to draw Bohr models, just for any of you that may still be a little bit confused about how to do that. So I'm going to start off with sodium. And I've given you the nuclear notation. Remember, the nuclear notation, the top number is your mass number, which is the sum of your protons and your neutrons. And the bottom number is your atomic number. So that's equal to your protons. So the first thing I want to do is I want to go ahead and draw the nuclear composition of sodium. So I'm going to draw a circle, and this represents our nucleus. And just for shading purposes here, just so you can distinguish, I would suggest maybe shading it at the end to represent the nucleus so you don't confuse that for an energy level. So in the nucleus of this sodium atom, we should have 11 protons. So 11 protons. And remember, to get your neutrons, you subtract here. So 23 minus 11 is going to give you 12 neutrons. So you want to indicate that there are 12 neutrons also in the nucleus. Now, remember in class today we talked about how you can look at your periodic table, and the period that the element is in lets you know how many energy levels to draw around the nucleus. So since sodium is in the third period, we're going to draw 3 energy levels around the nucleus. 1, 2, 3. All right, so another thing that I want y'all to understand is that on our Bohr model, each energy level, in fact, does represent what you would find on that particular energy level for each of the periods. So the first energy level in our atom only has 2 electrons in it, because if you look at the first period on the periodic table, you'll see there's only hydrogen and helium in that first period. So that first ring on our Bohr model is representing the first 2 electrons that would fill the energy level, which are hydrogen and heliums. Technically, they are electrons. So I'm going to put 2 electrons in that first energy level. And then in the second energy level, if you count across lithium all the way to neon, 1, 2, 3, 4, 5, 6, 7, 8. Notice there's 8 elements, which correspond to your 8 electrons that would go in the second energy level. And we're going to stop at sodium. So sodium is the first element in the third period. So we're going to put 1 electron in the third energy level. Now I'm going to make a little key here where 1 electron is equal to each of my dots, okay? So in the first energy level, we're going to place 1, 2 electrons. In the second energy level, we said there were 8. So we're going to put those in pairs, 2, 4, 6, 8. And then the last electron goes in the third energy level, and that's sodium's valence electron. Now remember, the outermost electrons are the valence electron. Since sodium is in group 1A, he should have 1 valence electron. Notice the group number is 1A for sodium, and that group number we learned today tells us the number of valence electrons. So we had 3 energy levels around our nucleus because sodium's in the third period. As you fill in your electrons, the first period has 2 elements. So those are your 2 electrons you see in your first energy level. The second energy level has 1, 2, 3, 4, 5, 6, 7, 8. So those are the 8 electrons in your second energy level. And we're stopping at sodium. So he's the first element in the third energy level. So there's only 1 electron that goes in the third energy level. If you add up the total electrons here, we should have 11 because this is an atom. So it should have the same number of protons as it does electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. He has 11 electrons. All right, let's look at another example. Let's look at sulfur. We'll do sulfur. So the nuclear notation for sulfur is going to be a 32 over 16s. So I'm going to draw the nucleus again. I'm going to shade it in just a little bit just to distinguish between the nucleus. I don't want you to confuse that pink border there as an energy level. It's not. All right, so in the nucleus are our protons and our neutrons. So we should put 16 protons. And then when you say 32 minus 16, you're going to get 16 neutrons. That's in the nucleus. Now, go back and look and see how many rings to put around the nucleus. So find his period. Looking at your periodic table, sulfur is here. So you look and see that is also in the third period. So we're going to put 3 rings around our nucleus. 1, 2, 3. So just as we did before, you're going to have 2 electrons in your first energy level because there's 2 elements in the first period. In the second energy level, you count across, there's 8 elements. So those are the 8 electrons in your second energy level. And in the third energy level, which is our valence shell here for sulfur, we're going to put 1, 2, 3, 4, 5, 6. So notice he's the 6th one over. He should have 6 valence electrons. He is in group 6A, which corresponds to what we learned today in class. So again, we're going to put 2 electrons in the first energy level, 2, 4, 6, 8 electrons in the second energy level. And then again, we're going to put 1, 2, 3, 4, 5, 6. 6 valence electrons. He's in group 6A. 1, 2, 3, 4, 5, 6. He has 6 valence electrons. If you total up the total electrons here, you should have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's do one more. So for example 3, I'm going to look at calcium. I'll go ahead and write the nuclear notation here for calcium. So we're going to put 40 for his mass number and 20 for his atomic number. Let's do your nucleus. You might want to pause it here if you want to try this one on your own and then just mash play when you're done to check it to see how you did. I'm going to fill in the nucleus here. 20 protons because that's his atomic number. 40 minus 20 gives you 20 neutrons. Now let's figure out how many rings to put around the nucleus. Calcium is in the 4th period, so we should put 4 energy levels. 1, 2, 3, 4. Again, first energy level has 2 electrons. The second energy level has 8 electrons. The third energy level, 1, 2, 3, 4, 5, 6, 7, 8. And in the fourth energy level, 1, 2. He's the second one over. He should have 2 valence electrons because he's in group 2A. So you should have 2 in the first, 2, 4, 6, 8 in the second, 2, 4, 6, 8 in the third, and then his valence shell should have 1, 2. Okay, we'll talk about tomorrow how to draw the Bohr models for ions, and we'll review over this some more in class as well. Hope this helps.